Hello everyone, welcome back. In this episode, we'll tackle one of the most common bugs in multithreading, race conditions. We'll see how do we fix them using synchronized. So what is a race condition? A race condition occurs when multiple threads access and modify shared data at the same time, and the outcome depends on the thread scheduling order. So let's say there are two threads and both the threads are trying to increment a counter from 0 to 100. Now final count should be 2000, but due to thread interference between each other and race condition, the count is not always 200. So we'll see by a hands-on example. I'll create a counter class and I'll just give a variable of type integer whose initial value is 0, and in increment method I'll just increment the count. Whenever this method is called, the count will be incremented by 1. Now to test this, I'll create two threads, create an object of counter. So as you can see, Copilot is suggesting or JetBrains AI is suggesting what I'm going to write. I'm going to write exactly the same thing. So we will test the race condition. We have written one main method where we are initializing the object of counter, and we will use the counter dot increment method for each thread. We have created two threads and we are running the counter from 0 to 1000, and for each uh, call we are incrementing the counter, so final output should be 2000. We have started the thread and we are joining the thread and waiting for one thread to finish, then another thread to start after that, after the previous thread. So it shows 2000, but it will not be consistent. As you can see, final count is 1822. Earlier it was showing 2000. Now it is 1937. So this is inconsistent. This is not always correct. So this is what a race condition is. To fix this, we have to use concept of synchronization. So what do you mean by synchronization is you go to the critical operation part of a method or of your logic and you apply the synchronized keyword. You say that this operation is critical and it should only be done by one thread at a time. Once it is done, then it should be this critical operation should be handed over to the other thread. So now if we test the race condition, it's 2000. So if we try multiple times or if you try n number of times, every time the count is 2000. Why? Because we have synchronized the critical operation. Now there is another way of synchronizing. Instead of at the method level, you can synchronize the block level, where you can say that it is synchronizing this object and this is the operation. We will test this once again. As you can see, final count is coming 2000 every time. Now synchronized over here is a intrinsic lock, which means the thread acquires the intrinsic lock of the object and only one thread can hold it at a time. This was about synchronizing a class having a critical operation. Now let's say you have a static method. How do you synchronize the critical operation under that static method? So you might have come across singleton class in Java, and it is a very famous interview question where you have to create a singleton class and you have to make it thread safe. So to make it thread safe, you might have used synchronized over there also. We will use the same example and show you how to thread safe a static method. So if you see, we have created one singleton class and we have made the constructor private to prevent the instantiation from outside this class. And we have given one public static method which gives you the instance. Now to make it thread safe, we have used synchronized. And instead of using synchronized here, we can use the synchronized at the critical method level. And if you notice, we are not passing this over here, this keyword. Instead of this keyword, we are passing the class name because it is a static method. And when you are synchronizing a static method, you should use the class. And we introduce a double checking because there might be a possibility that two of the threads entered this, and one of the thread while acquiring the lock, one of the thread is still acquiring the lock, another thread is has already instantiated the class. So in that case, you double check over here that instance is null. If it is null, then only you instantiate. So here we have discussed concept of singleton as well as concept of synchronization. Now to test this, we will again create one more test class, and in this test class we are just creating a runnable task to get the singleton instance. Now we have used three threads to execute this runnable task, and each runnable task is trying to get the instance of singleton. So conceptually, singleton is something which is just one instance throughout the program. So all the three threads should return instance hash code as similar. So all the instance hash codes that are returned upon running these threads should be same. Let's test this. As you can see, all the three threads got the instance of the singleton class which is same. So by using synchronized keyword, we have created singleton and we have thread saved. Now moving to our interview questions. So one famous question could be, what is the difference between synchronized method and synchronized block? Method locks the whole object. When you synchronize the method, it locks the whole object. And when you use synchronized block, that is the critical section, it lets you block the part of the code which we already discussed. So if you synchronize the method, it locks the whole object. But if you synchronize just the critical part, it locks only that critical part. Now next question is, can static methods be synchronized? We have seen here, yes, it can be. But the lock is on the class object, not the instance. I'll note that down. Next is, what is intrinsic lock? So intrinsic locking is nothing. Whatever we have shown here is all intrinsic locking, which means the lock acquired implicitly by singleton keyword is it's intrinsic locking. Now in the next episode, we'll unlock inter-thread communications, like how two threads will communicate with each other saying that, okay, I'm done, now you should start your task, and next thread will say, okay, I'm done, now you should start your task. So we will understand how we can achieve that. We will also see how producer and consumer uh, pattern works using threads. If you like this content, kindly subscribe. Thank you.